so circular measure, right? What we are going to learn here is first radians. So we have to know that radians, the pi, pi is 3.142. So the pi is equal to 180 degree. So 2 pi is equal to 360 degree. Okay, so more information here. So let's say we can keep using the pi to get more important angles. So for example, pi over 6 is equal to 30 degree. As you know, pi is 180 degree, right? So 180 divided by 6 is 30 degree. So pi over 3 is 60 degree. Then pi over 4 is 45 degree. And then pi over 2 is 90 degree. So these are the important angles. And how we change degree to radians. So you can see here, degree to radians, you multiply with pi over 180. So for example, you are given with some degree here. Let's say you are given with 135 degree. So you want to change it to radian. So you take 135 degree, multiply with pi over 180. Then you just use calculator to simplify between 135 and 180. So you will get 3 over 4. And the pi, you just leave it there. 3 over 4 pi radian. So after that, we have another formula which helps us to change radian to degree. So to change radian to degree, we multiply with 180 over pi. So for example, if you are given with 3 over 2 pi, so you can change it to degree by multiplying with 3 over 2 pi, multiplying with 180 over pi. So first you can cut the pi, and then 3 over 2 times 180, you will get 270 degree. So that is the formula about conversion. So after that, we have arc length S equal to r theta. So this arc length is the arc length of a sector. Okay, arc length of a sector. So this is the arc length. We call it S. This is the radius r, and then this is the theta. So you want to find the arc length. So basically, you take the radius, multiply with the theta. The theta is in radian. Okay, now the next formula, area of a sector, A equal to 1 over 2 r squared theta. Again, the theta here is in radian also. Okay, in radian. So basically what we can do is we can find the area of this sector by using this formula. Okay, so you have two formula here. The first one is to find the arc length. The second one is to find the area of this. Okay, now of course the formula is not enough. We need to take a bit more. So let's say if you have a sector like this, then you add a line here. So first, this line is known as chord. Okay, it's known as chord. So if you want to find the chord length, so we have to learn, we have to know what formula to be used if you want to find the chord length. So you either derive the formula or you memorize the formula. So if you derive it, you have to add a line in the middle, where here is 90 degree, here is theta over 2. Originally it is theta, so you divide, you cut a line in the middle, it become theta over 2. Okay, so then you can find out this particular length, which is here to here. Okay, this particular length, that is half of the chord length basically. So you use sine theta over 2 equal to opposite over hypotenuse. And then after that, you can get x equal to r sine theta over 2. And because of that, You know, x is just the half of the chord length. The chord length is the whole horizontal line, but x is just the green color line over there. So because of that, chord length is 2r sine theta over 2. So this is the formula for chord length. So you either memorize it or you try to derive it. And in terms of degree or radians for this theta, right, it depends on your calculator. Depends on your calculator. If your calculator is in degree mode, most people will set it in degree mode. Then this theta, you use degree. So if your calculator is set in radian mode, then this theta, you put radian inside it. Okay. So let's say one example. Let's say example. If you have something like this, you have here 5 cm, you have here 70 degree. So you are going to find the, okay, I shade this region. This region is called segment. It is arc length and chord length that join up to form segment. So to find the perimeter, let's say, find the perimeter and area of segment. Okay, so if you want to find the perimeter, so basically you have to find the arc length, then you add up with the chord length. Okay, so I find the arc length first, then I will find the chord length, or I find it together. Let's say perimeter S equal to r theta. This is the arc length. Then the chord length 2r sine theta over 2. Okay, so if your calculator is in degree mode, then how you press is like this: P equal to 5. This theta you must change to radian. Must use radian, this one. Okay, must use radian. So you change degree to radian then. So 70 times pi over 180. So you change that to radian. Plus 2r. R is 5. Sine. Okay, our calculator is now in degree mode. So you can use degree straight away. 70 divided by 2. This is degree. Okay, then we can just press everything like that, and then you will get the parameter. Okay, so let's say I just times everything here. So you will get 11.8 cm. Okay, so if let's say your calculator is in radian mode, and then your working will be like this: P equal to r theta plus 2 times 5 sine. The 70 you change to radian also. Like this. Then after that you will get, okay, let's say I change to radian mode, then I press calculator, times pi over 100. Okay, you will get the same answer, 11.8 cm. So that is the parameter. So now let's talk about the area then. To find the area of the segment. Okay, so what we need to do is we need to know that the we already learned the area of sector, so which is, if you look at this diagram, the area of sector is the whole sector like that. Okay, so you need to remove, or you need to minus the area of triangle. Okay, so to find out the area of triangle, so of course we have formula that we learned last time. So the area of triangle in general, okay, let's say I write it here. In general, if you have a triangle like this, here is A, here is B, here is C, here is angle A, here is angle C, here is angle B. So in general, area of triangle is equal to 1 over 2 AB sine C. Okay, so which is, you take A, you take B, then you sine the angle in between. Of course, you can take other side also, like for example, you do 1 over 2 AC sine B, or you do 1 over 2 BC sine A. So you have many options here. But when it comes to our triangle in this specific way, where you draw a chord here, so you will have radius here, radius over there. Okay? So what happened is, okay, let's see here. If you have a chord in this particular way, then the R and the theta. Okay, so to find this area of triangle, so basically we can use area equal to 1 over 2. Based on the formula here, right? You just take any two sides, multiply and sine the angle in between. So it is R times R square sine theta. So that is the area of triangle. And again, the theta here, right? Degree or radian depends on your calculator. Okay, I write down first. Degree or radian depends on your calculator. Okay, now let's say for example, I use back this one. And now I'm going to find the area. So let's take a look. So the area is equal to the area of sector minus the area of triangle. Okay. So if you are finding the area of sector, we must use degree. So which is 5 square. Then multiply with, the theta must be in radian. Theta must be in radian. So 70 times pi over 180. And after that, for the back one, 1 over 2 5 square sine. Okay, the theta over here, degree or radian, it depends on your calculator. So let's say your calculator is in degree mode. And then you just put it like 70 straight away. And then you will get the area of segment. So let's say I multiplied it to find out the value. So you will get 5.597, which is 5.60. Okay, so if your calculator is in radian mode, then the area 1 over 2 5 square, this one must use radian, 1 over 2 5 square sine, so the theta here must be in radian also, 70 times pi over 180. then you will get the same value, 5.6. Hold on. Okay, I think my calculator is currently okay. No, this one should be 3.53. 3.53, yeah. So when I change it to Radian mode now, let's see. Change it to Radian mode. In Radian mode, of course we have to get back the same answer. Yeah. 3.53. Okay, so area cm square. Okay, now let's see one example here. Triangle OAB is isosceles. So this is the triangle OAB. OA equal to OB, and ASB is a tangent to PST. PST is the arc length. Find the total area of shaded region in terms of R and theta. So we have to take the area of triangle minus the area of sector. So this is the other way around. Okay, so we put it like this. The area equal to, okay, let's say the area, I call it A, equal to 1 over 2. Okay, OA times OB sine 2 theta, that is the area of triangle, minus area of sector, 1 over 2 OP square, and then after that theta, 2 theta. That is area of sector. Okay, now we have to simplify it. So they want in terms of R. Okay, in terms of R. So what we can see here is R is the radius. So this one we can replace with R. Then how about OA and OB? So in terms of R, how long is it? So we need to know about that. Okay, so let's see. They just say it is a tangent. Okay, it is a tangent. ASB is a tangent, and then isosceles triangle. Okay, so let's see it in this way. So this is theta. Half of the right angle triangle is theta. Okay, so we consider this right angle triangle. Okay, the side here is R. Okay, then after that, here is right angle triangle. Okay, after that, okay, so what happened is after you have your right angle triangle in that way, so we can use the adjacent. This is the adjacent, and this is the hypotenuse of the right angle triangle. Okay, so we can do something like this. Based on the triangle that I put in red color, we can use adjacent hypotenuse, which is cos. I can use cos theta. Cos theta equal to adjacent over OB, and hence OB is R over cos theta. So R over cos theta is the OB. Okay. Now it is okay to put it in terms of R and theta. As I said, the answer is in terms of R and theta. Now we put it here. 1 over 2. OA and OB will be the same length. So R over cos theta power 2 sine 2 theta minus 1 over 2 r square 2 theta. Okay. Then after that, let's say I try to simplify the answer. Okay, so 1 over 2 r square cos square theta. The sine 2 theta I use trigonometry formula, which is 2 sine theta cos theta. So I cut the 2 with the 2 here. Then I can cut the cos, and then the back one I just cut the 2. I get r square theta. Okay, now I get r square, sine over cos is tangent, minus r square theta. So factorize the r square, I get tangent theta minus theta. Okay, so this is the area. Now part 2. When theta equal to 1 over 3, this is radian, and r equal to 6, find total parameter of shaded regions in terms of sub3 and pi. Okay, so to find the parameter, so let's say I call it P. Okay, so basically we have to find out all the side here, like AP, AS, okay, and then the arc length PS. So this is the parameter, and this side also. Okay, so basically you need to find the parameter of one side, then you times 2, then you get the whole parameter. Okay, so now let's work it out. I write down first. I'm going to take 2 times of AS plus AP plus the arc length of PS. Okay, so first I start from AS. So to find out AS, we have to use tangent. Okay, tangent. So imagine same one. Even on this side, it works in the same way because it is a right angle triangle. And we know this is R. So you want to find out AS, we have to use tangent. Tangent theta. Here is theta also. Tangent theta equal to opposite over adjacent. So AS over R. So we get AS as R tangent theta. So that's AS. So we write it here. R tangent theta. Then we have AP. So AP is, okay, just now we found OA already. Okay, we found OA. OA is R over cos theta. Okay, and because of that, AP is just minus with the radius. Okay, so let's work it out at the bottom here. AP. Okay, so AP is, okay, let's say I work at the side first. Or even AS I work at the side also. Okay, will be easier. It won't be so complicated. So I transfer at the side first. AS. Okay, just now AS is R tangent theta. So the R is 6. The theta is 1 over 3. 1 over 3. Okay. It's a typo error actually. This theta should be theta equal to 1 over 3 pi. Typo error. Okay, so 1 over 3 pi. So tangent 1 over 3 pi, that is tangent 60 degree. Tangent 60 is sub 3. So 6 sub 3. That's AS. Now AP, right? Like what I discussed with you just now. If I look at the pictures, so we have to know that AP is OA minus with radius. So OA we found out already. Again, it's from here. R over cos theta. So I write down first before I substitute. R over cos theta minus with R. Okay, now I substitute with value. The R is 6. And then the theta is pi over 3. So minus with 6. Then we get 12 minus 6, which is 6. And that is AP. Okay, now we find the arc length of PS then. Arc length of PS. Okay, so as you can see, we have quite direct for this case. We have radius and theta. We can use S equal to R theta. Okay, so R theta. So R is 6. Theta is pi over 3. So we get 2 pi then. Okay, so now we substitute all the values into the formula here. So AS is 6 sub 3. AP is 6. This is 2 pi. Now we add up and we times 2. So we get 12 sub 3 plus 12 plus 4 pi. And that is the answer.